And just a short note on the language around these issues. So we use the word replication to mean repeating the same study. So trying to get the same or similar results by doing the same thing that was done earlier. And this is, of course, it's not the dichotomous uh, because obviously time exists and whatever replication you're going to be able to do is going to be in a different time than the original and different participants and so forth. So there are going to be things that differ from the original setting. But of course, there should be some generalizability that would allow you to replicate something that has been done before. If the idea is that there is a some sort of an effect that is some that has been uh, discovered or something that can be actually used in the real world. For example, when we're trying to do some evidence-based policy or decision making or so forth. And the other part of this is reproducibility. So taking data from some study and using the analysis scripts and getting the same results. So it's much easier to reproduce something because you only need to run it on a computer, basically, if you have the data. And so this is something we touched on previously, just a personal observation that different fields of science, they have either tried to look at their practices in terms of replication and replicability and reproducibility. And they either have done the introspection or they think that they don't have any problems, because it seems that every field that has actually done this introspection has found the research, some issues behind the published research. And this is quite important because originally when this whole conversation started, there was a lot of talk about that this is not our problem. It's those guys over there who don't know how to do reproducible or replicant science. And another note on the language is that not everyone really likes the word crisis. This was a panel I was in, and there is a one psychology researcher who was of the opinion that there's actually no crisis here. It's just speaking about these issues it means that we are actually correcting practice. But it might be that the self-correcting nature of science actually just takes a very long time, for example, 100 years or something. Which is, as a practitioner, if you want to do things in the real world now based on science, it's sort of unsatisfactory, let's say. In this panel, my recommendation was to for researchers to be as open and transparent as possible, because that really relieves you from the fear of making mistakes. Because it's not about, research is never about not making mistakes. It's about learning from mistakes and being able to provide material, which is something that other people can also learn from. And next I'm going to talk about medicine, and I'm going to first tell you why I'm going to talk about medicine, because this is sometimes confusing when we talk about social science issues. So most medical research has a mandatory access to statisticians. So you often have like large trials and so forth where you actually have hired statisticians to make sure everything goes well. We don't have this in social science. and the access to statisticians can be very, very difficult. I visited the University of Cambridge. I did a research period there a couple of years ago, and they were I was in the Department of Public Health, and I was really happy because they had the like statistics. They were in the same building as the statistics department, and I thought that, okay, so these guys probably have things much better off than we do when we might not ever meet any statisticians in our day-to-day work. But it turned out that they had exactly the same problems with accessing statisticians to help with their studies. Medicine also has a huge impact on human health and well-being. So it's we sometimes people say that, okay, so what I'm doing is not that important, or what those studies are not that important, so we don't need to pay that much attention to the nitty-gritty details of the studies. And medicine also has like a very strict safeguards for overseeing research in terms of ethics and methodology and publishing. So it should be doing very well in comparison to social science. So I'm just going to show you a couple of examples. So here was one study where they looked into subgroup claims in randomized clinical trials. So what a subgroup claim here means is that you might have studied some population, and maybe there's an effect or there's no effect, but then you would go into looking into subgroups of your population. So you would look at, okay, so what about men or women? Do we see the same effect there? Or what about young people, old people? What about white people, or rural people living in rural environments, and so forth. So you would look into these smaller and smaller subgroups, and you might look into, okay, so what about white people living in urban environments who are 15 to 20-year-olds? So what if there's an effect in those guys? So people sometimes do this, and you can do it well if you have the right statistical tools to do it and you apply them correctly. But in this case, they looked into the literature and what was in these subgroup claims. What they found 117 subgroup claims. And it was interesting that only 46, so about 40%, were actually supported by their own data that was in the paper. And of those, only 5 were attempted to replicate, and of those 5, none were successful. This is kind of worrying, of course, because we're talking about medicine, which should be the best field we can imagine, basically. And another thing in medicine was like there was a large discussion about outcome switching, where there was this project called the COMPARE Trials project. And what this COMPARE project did was that they compared, because in medicine you have to usually publish what you're going to do prior to actually doing it. So you have this protocol, so these are the things we're going to look at. And then you have the research report, which says that these are the things we actually looked at. And the point of this system is that Because sometimes when you do a study, what people do is they look at the data and they find out that there is that they did the study to study something completely different, but they find an effect on something else or a subgroup. So we have the uh, 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 men who are under 160 centimeters and of the highest income bracket who show this magnificent effect. And it's of course it's not so persuasive if you say that, okay, so I actually took 1,000 different demographic segments and I found these two segments where we found this effect. It's not that appealing. But if you say, hey, I did a study and I had this theory that there is this one population segment or these two population segments, and we did the study to study these two population segments, and we found what we were looking for. So that is a lot more persuasive. But the problem is that usually people go on to do something that they study 1,000 different segments, and then they write the report saying that we went to look only at these two segments and we found exactly what we thought about because we are so smart. And the problem is that if you write the papers this way, people end up thinking that you're actually more you found something much more robust than you actually did. So this system of publishing the protocol prior to doing the study or publishing the study itself is, or collecting the data, is meant to correct and prevent people from doing this sort of a shenanigans. So this project, the COMPARE project, it looked at a lot of these sorts of papers. They looked at the protocols and they looked at the published papers, and they found out that these very rarely coincided. So people publish a protocol saying, "Hey, we're going to do this and this and this," and then they publish a paper saying, "Oh, we were actually going to do this and this and this," which don't match what they actually really were going to do in the study. So these guys in the COMPARE project, they did a lot of analysis on this, and then they sent it to many different largest medical journals. The results in some were like very receptive, but then there were others. So we have like the 5 biggest medical journals there, like the British Medical Journal, the Lancet, and JAMA is Journal of American Medical Association, which is one of these top 5 medical journals, most respected medical journals. And when these guys in the COMPARE project, when they sent their report about these papers published in JAMA and how they differed from their original protocols, the people in JAMA said, "Yeah, well, what do you do? I don't know. This isn't something that really interests us." And so this was quite, let's say, disconcerting.